Let's talk about building solid and reliable net APIs. It's not just about writing code, it's about making sure that code works seamlessly with other parts of your application. That's where integration testing comes in. Imagine you're building a house. You wouldn't just build the walls, roof, and foundations separately and hope they magically fit together, right? You'd want to make sure they connect properly. Integration testing is like that for your code. It's about testing how different parts of your API work together, like making sure your database calls, external services, and everything in between are playing nicely. Why is this so important? Because in the real world, software is complex. Bugs often hide in the spaces between different components. Integration testing helps you catch those bugs early on, saving you headaches and ensuring your API is rock solid. In the next section, we'll dive into a powerful tool for integration testing in-memory databases. Stay tuned. So, we know integration testing is vital, but what's the best way to do it? One word: in-memory databases. Think of them as lightweight, temporary versions of your real database. Why are they so great for testing? First off, speed. In-memory databases live in your computer's RAM, meaning they are blazing fast. Tests run quickly, giving you faster feedback on your code. Second, isolation. Because they're temporary, each test gets a fresh, clean database. No more worrying about leftover data from previous tests messing things up. But wait, there's more. In-memory databases are also super easy to set up and tear down. This makes your tests more efficient and less prone to errors caused by complex test environments. In the next section, we'll walk through setting up an in-memory database step by step. Get ready to supercharge your testing. Time to get our hands dirty and set up our in-memory database. Don't worry, it's easier than you think. We'll be using Entity Framework Core, a popular tool for working with databases in .NET. First things first, install the necessary NuGet packages. We'll need the in-memory database provider for EF Core. You can do this easily through the NuGet Package Manager in Visual Studio or by using the .NET CLI. Next, let's configure our application to use the in-memory database for our tests. We'll modify the connection string in our application's configuration. The connection string tells our application where to find our database. For our in-memory database, we'll use a special name that EF Core recognizes. Finally, we need to tell EF Core to use the in-memory database provider. We can do this when we're configuring our application services. That's it. We've successfully set up our in-memory database. Now, our tests can use this lightweight database to run quickly and in isolation. Section 4. Writing integration tests with in-memory databases, a practical example. Now for the fun part, writing actual tests. Let's imagine we have a simple API endpoint that retrieves a list of products from our database. We want to write an integration test to make sure this endpoint is working correctly. First, we'll set up our test class and inject any necessary dependencies, like our API's controller. Then, using our in-memory database context, we'll seed some test data, a few sample products. Next comes the actual test. We'll make a request to our API endpoint and examine the response. We'll assert that the response status code is OK, which is 200, and that the returned data matches the products we seeded in the database. This is a simple example, but it demonstrates the power and simplicity of using in-memory databases for integration testing. We can test our API's interaction with the database in a fast, isolated, and controlled environment. Section 5. Common pitfalls and best practices. While in-memory databases are incredibly useful, there are a few things to keep in mind to avoid common pitfalls. First, remember, it's not your production database. In-memory databases behave slightly differently than real databases. Avoid relying on specific database features that might not be fully supported in memory. Second, keep your test data small. Since in-memory databases live in RAM, using large amounts of test data can impact performance. Stick to just enough data to cover your test cases effectively. And finally, clean up after yourself. Always make sure to clean up your in-memory database after each test. This ensures a fresh start for subsequent tests and prevents data from one test interfering with others. By following these best practices, you can maximize the benefits of in-memory databases and ensure your integration tests are reliable and efficient. Section 6. conclusion, embrace in-memory databases for robust net API testing. And there you have it. We've explored the world of net API integration testing with in-memory databases. We've learned why they are crucial for building robust APIs, how to set them up, and how to write effective tests. Remember, in-memory databases are your secret weapon for fast, isolated, and reliable testing. They help you catch bugs early, ensure your API components work seamlessly together, and ultimately deliver a better experience for your users. So go ahead, integrate in-memory databases into your testing workflow and watch your net APIs become more resilient than ever before.